So here we go. We're going to get started in the workbook. This is Intro Algebra. I'm the instructor, Dr. Gavin, and with this video, we're going to cover Chapter 1. We start out talking about whole numbers, and this chapter has 4 sections. We're going to talk about, what is a whole number, and as you can see on this first page, place value. Then we're going to talk about rounding numbers, exponents, and probably most importantly, the order of operations. Okay. So whole numbers and natural numbers, two different kinds of numbers mentioned in this first paragraph here. Whole numbers include the natural numbers. So when we say natural numbers, we're talking about these numbers starting with 1, 2, 3, 4, 5, 6, and so on. Okay, just numbers that you would use to count things with. Okay, whole numbers, all natural numbers are whole numbers, and so to write the list of whole numbers, we could write the same numbers, 1, 2, 3, 4, 5, 6, and so on, and every number beyond this for natural and whole would just simply be both. 7's both natural and whole, 8's both natural and whole, but the whole is not exactly natural numbers because we include 0 in the list of whole numbers, and 0 is not a natural number. So that's the only difference between the two types. Okay. Down below we have a number listed, 123,456. Okay. It's not a decimal number. We could insert a decimal. This is considered a whole number, or we could call it a natural number. And in that case, the decimal is automatically assumed to go behind the last digit. Alright. Now, each one of these digits represents a certain amount in regards to the place value. Okay. We can actually take this number and break it apart in terms of the different place values. So you see a 1 here, okay, the first digit, from left to right. You see a 1 here and an arrow leading to it, and it says it's the 100,000th place. So in other words, we could represent this number by writing 1 times 100,000. Okay. But then we need to do the same thing with all of the other digits. Okay. This next one, 2, is in the 10,000th place. And so that simply represents a 2 times 10,000. Okay. Now, these two alone do not represent the full number, the 123,456. We have to go through each digit and write it out according to the place value. So for the next one, we've done the 1, the 2, and now we're going to do the 3. It's in the thousandths position, and so we have 3 times 1,000. 4 is in the hundredths position, and so we have 4 times 100. We have a 5 in the tens, and 10 is written 10, and we have 5 times 10. Okay, so 10, 10, 100, you add a 0, 1,000, you add a 0 to the 100. Okay, our number system is based on 10. Okay, so each place over is increased by a factor of 10. And finally, we've got a 6, and we can write this, since it's in the ones place, as a 6 times 1. Now if you just take any old calculator and you write 1 times 100,000, and then you add to it 2 times 10,000, and then you add 3 times 1,000, and then you add 4 times 100, 5 times 10, and 6 times 1, you'll get this number. Okay, so hopefully that gives you a little bit more explanation in regards to the places. But another way to run through this is just to simply say, here's the decimal point. The place immediately to the left of the decimal point is ones, and then we proceed with tens, hundreds, thousands, 10,000s, 100,000s. Okay, so in example 1, we need to be familiar with which place is what. Alright, because they tell us that we want to take a particular number in example 1, 567,832, and we want to round it to different place values. So well, actually we're not going to round it. We hadn't got to rounding yet, but it is important to know place value to round. We simply just want to state the digit in this particular place value, thousandths place. Okay, when you think of 1,000 and write it out, okay, you write a 1 and 3 zeros. So in other words, we are looking, and this is the ones. Okay, if we were to write a decimal point associated with 1,000, it would go right there. Okay, so we start with the first digit and we go 1, 2, 3. All right, so from the ones, it's 3 places over. So 1, 2, 3. Okay, we could say this is the 4th digit to the left of the decimal place, but 7 is in the thousandth place. Okay, tens place, well, if you write down a 10, we go over to the second digit. So 1, 2, 3. Ones place is the first place, so that's a 2. 10,000. Okay, just focus on writing 10,000 if this gets confusing. You don't know exactly how many digits to go over. Write out 10,000, and so we need to go 1, 2, 3, 4, 5, the 5th digit from right to left. So 1, 2, 3, 4, 5. That would be the 6. Hundredths place, 1 with 2 zeros. 1, 2, 3. So 1, 2, 3 takes us to the 8. 100,000ths place, 100,000. 1, 2, 3, 4, 5, 6. Okay, where is the 1 located in 100,000? 1, 2, 3, 4, 5, 6. The 5. Alright. That takes us to the next page, where we'll lay out the 2 rules for rounding. Okay. Let's just skip to the rules. They're real simple. Case 1. Okay, we want to round to a particular digit. If the number after the chosen digit is 0, 1, 2, 3, 4. Okay, keep the chosen digit and change all the digits to the right to 0, rounding down. Alright. Case 2, if the number after the chosen digit, and this chosen digit is a particular place that we're going to be told to round to. For instance, if we were told to round to the 10th place, then we would find the digit in the 10th place and then look immediately to the right. And if that number was 5, 6, 7, 8, or 9, we would increase the 10th place digit by 1 and round all the other numbers off to 0. Or just change them to 0. Okay. Example 2 says rounding to tens or hundreds, and they give us the number 61. It says round it to the nearest tenths. This may not be entirely necessary, but we'll label the place values of this number. 6 is in the tens, and 1 is in the ones. So the place that we want to round to is the place where the 6 is located. So we want to, there's one of two things that are going to happen when you round. You find the place, the digit that's in the place that you want to round to, and you say, well, I'm either going to keep this 6 or I'm going to increase it by 1. Those are the only two possibilities. To figure out which one you need to do, you simply look over to the right. Okay, the number immediately to the right of the tenths place is a 1. Okay, that falls into case 1 above. I'm not going to scroll back up there, but case 1 says if the digit is 0, 1, 2, 3, 4, then you keep the digit in the place that you're rounding to. So in other words, to round this to the tenths place, we would simply write 60. Okay, it's closer to 60. It's only 1 away from 60. It's closer to 60 than it is 70. So we wouldn't want to increase 6 to a 7. We want to round down. Example 3. New number, round 2,519 to the nearest hundred place. Alright, so I'm not going to label all of the places. I'm just going to simply draw an arrow to our hundreds place. Okay. A 5 is sitting there. And we were told here that we want to round to the nearest hundred. Well, if we look at this number 5, that means we have 500. And if we read the other digits along with it, we have 519. So, in other words, which number, which hundred is this closer to? 500 or 600? Okay, well, we're only 19 away from 500, so it sort of makes sense that we would just stay with the 5 in terms of the hundreds. Okay, we are 81 away from 600, so we wouldn't want to round this up. Just a different way of looking at it. If we go with what the workbook's telling us, then all we do is we just simply look to the right. It's 0, 1, 2, 3, 4, and we round down. In other words, we keep the 5. We don't actually decrease it. Okay, and that's maybe what you would assume by hearing the phrase round down, but we just keep the 5. So 2,500 is the number that we're looking for. Okie dokie. Example 4, we've got 7,520, and we want to round that to the nearest thousands. Or, I'm sorry, thousand, not thousands. Well, we have a 7 in the thousands place. Thousands. Alright. We simply look to the right, and now we fall into case 2. 5, 6, 7, 8, 9. When we have that digit to the right of the place that we're rounding to, we increase this digit by 1. So, in other words, 7,520 is closer to 8,000 than it is 7,000. And so that's what we round it to, 8,000. Alright, the next page, our third section, and most of these chapters are pretty short. So we're already in the third section, and we're only 14 minutes into the chapter. Well, we're talking about exponents, and we're only dealing with whole numbers that have exponents attached to them. An exponent is just a shorthand way of writing repeated multiplication by the same number. Okay, and we have some letters here. Okay, you may have not been ready for that, but already we see some letters. Well, this is just sort of giving you a rule. When you see letters involved with some sort of explanation or rule, it simply means that these letters could be any number that you wanted to replace the letters with. Okay, in this case, it's sort of saying, well, n can't be any number, it has to be one of the counting numbers, the natural numbers. Okay, if that's the case, then some number x, and x could actually be any number. They didn't put any restrictions on it, but again, we're just going to deal with whole numbers for the time being. Alright, so in other words, x could be any whole number. So for instance, I could say 3, like they did above. Okay, 3, it's what I would refer to as my base. And now, with the example that we were given, they gave us an exponent of 4, and we write 4 off to the right as a superscript with respect to the 3. Okay, so if you see something, I'm just going to draw a box. If you see something with a superscript, then it's up above and to the right. If you see something with a subscript, then it's down to the right. Alright, well, an exponent is a superscript. So we write it this way, 3 to the 4th. And that just simply means that we have 1, 2, 3, 4 threes, and they are all multiplied together. This is not a decimal point. This represents multiplication. So another way to write this would be to put the traditional multiplication symbol in between. But as you can see in algebra, we're going to be using variables, okay, letters that represent numbers a lot. And x happens to be one of those letters, and one of the most common letters that we use in algebra. So we want to avoid this traditional multiplication symbol, and we just substitute a dot with that. Okay, a dot between two numbers indicates multiplication. Okay, so this is 3 to the 4th power. That's what we would call this if we were going to read it out loud. 3 to the 4th power equals 3 times 3 times 3 times 3. Alright. 3 is the base. Let's see if I can put this in a different color. 3 is the base, and then we have 4 is the exponent. Okay. Now we were given x to the n, and we were told that n is a natural number. So sort of a tricky instance of an exponent is 8 to the 1st power. Well, that just simply means we have 1/8, and so 8 to the 1st power is the same thing as 8. Okay, 8's the base, 1's the exponent. So in other words, if you see a number just sitting by itself, for instance, if I wrote the question, what is the exponent of, let's see, just to pick a number, 7. Well, you don't see a superscript attached to this number. It's just a number by itself. Well, we could write this with an exponent. We could say that 7 is equal to 7 to the 1st power. And so you should respond by saying the exponent is 1. Okie dokie. So example 5 wants us to evaluate some expressions that have exponents. So 4 is the base, 2 is the exponent. This means that we have two 4's, and they're multiplied. So 4 dot 4. 4 times 4. That's 16. 5 to the 3rd power is 1, 2, 3 5s, and we put a dot between them to show multiplication. And we don't have to do all of this in our head with one fell swoop. If you don't deal with numbers a lot, then that would probably be difficult. But in this case, we can just do two numbers at a time. 5 times 5 is 25. And we use these two 5s to get to 25, so we mark them out. And then we just bring our 5 down to the next line, and we say, well, 25 times 5 to complete the exponential expression, that would give us 125. So 5 to the third power is 125. So like I said, exponents are simply a shorthand way to write repeated multiplication of the same number. Okay, example 6. We see we have a long list of numbers multiplied, and they happen to be the same number in each case. So here is a practical use for exponents. Okay, we have 1, 2, 3, 4, 5 12s. And they're all multiplied. That's a very important point to make about this expression. We can't have division or subtraction or addition mixed up in between these 12s. Multiplication between each 12. They're all multiplied. We've got 5 of them, and so we just say this is equal to 12 to the 5th power. Alright, we've got 1, 2, 3 7s, and so this would be equal to 7 to the what power? 3, the number of 7s that are being multiplied. Okay. Example 7, powers of 10. 10 is one of our favorite numbers to apply exponents to, especially natural exponents, which I couldn't do a decimal exponent in my head. But we're just simply talking about natural exponents for right now. 10 to the 4th power. Well, you could do it with your calculator, but keep in mind that you cannot use your calculator on the first test, so that's not really an option at this point. We have to apply our understanding of what exponents represent, and so x to the 4th power, or I'm sorry, 10 to the 4th power. Let me write that out in words. 10 to the 4th, well, I'll write that out in words too. 4th power. Okay, that's a way to pronounce that, 10 to the 4th power. Well, it means we have 1, 2, 3, 4 10s, and we want to multiply them together. A real simple way to do this is to say, well, if I take one 10 and I multiply by 1, 2, 3 more 10s, every time I do that, it adds another 0. So 10 to the 4th power just simply means that I have a 1 with 1, 2, 3, 4 zeros behind it. Okay, so that's why we like 10. As long as we have a natural number exponent, let's say I write down another example, 10 to the 7th. We don't actually have to go through and multiply these in our head to answer this question. 10 to the 7th would mean we'd have a 1 and 1, 2, 3, 4, 5, 6, 7 zeros. So in other words, 10 to the 7 also is another way to write 10 million. 10 to the 4th power is a way to write 10,000. Just for another example, 10 to the 3rd power would be 1 with 1, 2, 3 zeros. So 10 to the 3rd is 1,000. and it always will be. Okay, here is a section in the workbook that is very important. Um, this is not going to go away. It's very important that you learn this order of operations. Okay, because algebra, I guess if you were going to define it in one simple sentence, algebra is simply knowing the order of operations forward and backwards. Okay, we go forward through the order of operations to evaluate an expression of numbers, and then we go backwards through the order of operations to solve equations, which I'm sure you already know. That's where we're headed in this class. That's the whole goal, I guess you could say, of algebra, is to learn how to solve equations with variables in them. Okay, so um, this order of operations is very important. Maybe you've heard the mnemonic PEMDAS. Well, it simply can be remembered through this sentence. Please excuse my dear Aunt Sally. And each one of these abbreviations, P, E, M, D, A, S, they represent a mathematical operation. Okay, that's why we call it the order of operations. And we're dealing with add, subtract, multiply, divide, etc. And we've actually learned one more in the previous section, and that's where this E comes in. E represents exponent. Okay, so we have the M, D, A, and S for multiply, divide, add, subtract, but we have two here that you may have not dealt with before. Okay, so the P for parentheses, this could be a new one. It says perform all calculations within each pair of grouping symbols. So we use P so that we can turn this into a sentence, but we're not only talking about parentheses. You need to keep in mind that this could be any sort of grouping symbol, which includes brackets, not just parentheses. So we take the brackets or parentheses and we work from inside that grouping symbol first. Alright, and example 8 gives us something to chew on in regards to parentheses. It comes first in the order of operations, regardless of what other operations are on the outside. For instance, we see here that subtraction is outside, and here is a symbol for mathematical operation division. Division is inside. So the parentheses are telling us just that. We don't go from left to right, as you might assume, in all cases. We follow the order of operations, which tells us that we do parentheses first. Look inside the parentheses. There's only one operation. It's division. We have to do the division before we do the subtraction. Okay, so what does that look like? I'll go ahead and write this out again. 4 divided by 2. Well, in algebra, you'll be a lot better off if you work problems one line at a time, line by line. So we take this line and we change one thing about it, and we write that down in the line below, and then we take that line and change another thing about it, or perform one more operation, and then whatever we get from that we write it on the line below. Okay, we just successively go down line by line until we've completed the problem that we're working. Okay, so the first thing is to do what's inside the parentheses. Okay, 4 divided by 2, well, that is 2. 4 divided by 2 is 2. And so inside parentheses, I replace 4 divided by 2 with a 2. And I didn't bother with anything outside of the parentheses. I'm following the order of operations. So everything outside gets left alone. In other words, I just copy it down on the line below. Now, when you see a set of parentheses that simply enclose a number by itself, then you really don't need the parentheses anymore. This is the equivalent of just a 5 subtract 2. Okay, you can drop the parentheses. There's only a single number inside the parentheses. So this is the only operation that we have left, subtraction. 5 subtract 2 is 3. And we're done. Alright. E exponents, find the values of any exponential expressions. Next, well, there were no exponents in this expression, so there's really nothing to do there. Let me see if they're going to give us an example. I'll just make up an example. Perhaps we were intended to just skip exponents and move right on to expressions just involving multiply and divide. Maybe they were saving this for later, but I'll just go ahead and make something up. Let's say we had this 5 minus 4 divided by 2, and then outside of the parentheses we had a 2 as an exponent. Okay, just to give you some example. Well, order of operations is please excuse. P is for parentheses, so we do the same thing that we did before. We start inside the parentheses. 4 divided by 2. The 2 is the exponent. It's on the outside, so we ignore it. We would simply write 4 divided by 2 is 2, and then copy everything down exactly the way it's written above on the outside of the parentheses. Now, in this case, which is different from the one above, in this case we have subtraction and exponent. We have two mathematical operations. According to the order of operations, E comes first before my dear Aunt Sally. Okay, there's subtraction and there's exponent. We have to do the exponent first before we subtract. Okay, what is 2 squared? 2 squared is 2 times 2, which equals 4. So we replace this entire expression with a 4. And now we can finish the last operation, subtraction. 5 minus 4 is 1. And we'll do plenty more of those later. So one example is definitely not enough. We'll see more examples later. We're going to go look at some examples that include these other operations. Okay, we're going to look at least one example of each of the operations in the order of operations. So after exponents, we have my dear, multiply, divide, and if multiplication and division are mixed and they're side by side, then we work from the left to the right. Okay. So, next page, that's exactly what we have. We've got 8 divided by 2 times 2. So the m does come first, but in this case we've got multiplication and division, and we want to take this expression and go from left to right. So division is what we're actually going to do first. So You can't just take PEMDAS, PEMDAS, and just run with it. Okay, you have to understand it, and that's what we're trying to iron out here with all these examples. So, multiplication division, 8 divided by 2 must be performed first, and that gives us 4. And we bring over the 4 times 2. Okay, 8 divided by 2 is 4, so 4 replaces that, and we bring over the times 2, and now we finish it. 4 times 2 is 8. So if you look at this, this is a good example of what can happen if you don't follow the order of operations. Let me write this down again and do it in the wrong order. Let's say you said, well, let's do the multiplication first, which is not correct. Then this 8 divide would just sort of sit off to the side, and we would do 2 times 2 first and get a 4, and then finishing with the last operation, 8 divided by 4, we'd get a 2. Doesn't work out to be the same number. Okay, we followed a different order and got a different number. That happens a lot if you do not follow the order of operations. So this is wrong. Okay, you have to learn to use the order of operations the proper way. When division and multiplication are side by side, you go from left to right. Okay, so with this next expression, multiplication division, the order swap now, and so we do multiplication first because it's on the left. 1 times 6, 6. We copy on this out to the side of the 6, divide 3 because we didn't apply it, and so now we say 6 divided by 3, and we get a 2. Okay. In this situation, you'd actually get the same number even if you did it in the wrong order, and that's probably one thing that confuses a lot of students. Okay. In algebra, sometimes you can make a mistake and end up with the same answer. Okay, just to clear that up. But more times than not, it's going to lead you in the wrong direction if you don't know the order of operations correctly. So, if we did it the wrong way, 6 divided by 3, we get a 2. And then if we multiplied it by the 1 on the left, we'd still get 2. Okay. If I see that you've done it this way, then I'm going to count it off on the first test. You have to go from left to right. Okay, even though you got the same answer, you used the wrong process. Alright, the last two words in the mnemonic, Aunt Sally, they represent add, subtract, and again, when we have addition and subtraction mixed together, we go from left to right. So we've got 3, subtract 2, add 1. 3 subtract 2 is farther on the left, so we say 3 minus 2 is 1. We copy down the plus 1 behind it, and now we finish the addition, 1 plus 1, and we write 2. Okay. If we had did it the wrong way, we would get a different number. If we went from right to left, 2 plus 1 is 3, and so we copy down the 3 and the minus. 3 minus 3 is 0. That's the wrong answer. Got to go from left to right when addition and subtraction are side by side. Next example, 1 plus 7. To do this correctly, we would add 1 and 7 and get 8, and then carry out the subtraction of 4 on the 8. So 8 minus 4, 4. Alright. And again, here's an example such that if you did it the wrong way, you'd end up with the right answer. If you did 7 minus 4 first, you would have 3. and then if you add 1 to 3 you still get a 4, but I do not want you doing that, because eventually it's going to lead you to the wrong answer. Alright, there are hardly any rules in this world that we can make that don't have exceptions, and here is one regarding division. Okay, one way to write division is with a fraction. Okay, so for instance, if I wrote 4 the traditional way divided by 2, I could rewrite this in terms of a fraction, and it still indicates that we take the 4 and divide it by 2. 4 fraction bar, 2 on the bottom. 4 in this case would be the numerator, 2 would be the denominator. Alright, I've simply wrote it in the same format, just a different order. So 4 divided by 2, traditional division symbol, is the same thing as fraction 4 over 2. Alright, in this case, we don't do division in the proper order in terms of multiplication and division before addition and subtraction. In this case, when we have a big fraction bar, what we do is we save that division for last. Okay, and what I mean by last is we don't want to carry out this division indicated by the big fraction bar until we have a single number on top and a single number on the bottom. So you look at this, and what you should see are two operations: addition and division. But this is a large fraction bar. The addition of 2 and 6 is completely on top and 4 is on the bottom. This is the exception. What we want to do is carry out the addition first and write 2 plus 6 is 8, and carry the 4 over to underneath the 8, and then do the division. 8 divided by 4 is 2. Another instance of a large fraction bar. This is division because we have the large fraction bar, and subtraction because we have 7 minus 3 on the bottom. We do subtraction first. 7 minus 3 is 4. Carry the 12 over to the top, just copy it over, and now we perform the division last. 12 divided by 4 is 3. Okay, so it's not enough to just simply remember, please excuse my dear Aunt Sally. You have to get practice with this. Okay, it's just like a sport. I could tell you how to shoot a basketball until I'm blue in the face, but just simply because you know how doesn't mean that you're going to be that good at it. It takes practice. Okay, and a lot of times on the tests that you take in this class, you don't have time to sit around and figure things out for the first time. Okay, it just has to be, you have to have practiced so much that it sort of becomes second nature. Alright, example 9, at this point we're just simply going to apply the order of operations. We're going to get that practice I was talking about. Example 9, we've got subtraction and we have division. So this one is pretty simple because there's no issue of left or right. I'm just going to write out my order of operations. We have subtraction and we have division, and division definitely comes first. Alright, so we write, let me copy this down because I want to work it out line by line. We're gonna ignore this subtraction in the 48. Okay, just maybe put your thumb over it as you work it, but we only want the numbers and the operation sign in between. So what comes first? We go down the list We evaluate. Okay, it even says it right here. Alright. No parentheses, no exponents, no multiplication. We do the division. 20 divided by 4 is 5. Now, we bring down everything that we didn't use in the previous step. Okay, and if I ever say step, this is what I'm talking about. We took this, we divided, and that brought us to this point. We took one step. Okay, so I write it on the line below. 20 divided by 4 is 5. So now we only have one operation here. So we could call this step 2. 48 minus 5, 43. Alright. Example 10. Got a lot of different operations mixed together here. We've got pretty much all 4 of the standard operations. I'll go ahead and write down the order again. We've got these 4. Alright. So keep in mind, there's a special rule whenever multiplication, division are involved, and then addition and subtraction are involved. It's not guaranteed to come into play every time. So that rule is simply just when multiplication and division are side by side, we have to go left to right. Now, this division is not right beside the multiplication. It's there on the opposite sides of this expression. Alright, in between this division sign and that multiplication, we've got other operations. So we don't have to do this left to right. Okay, now with addition and subtraction, they are side by side, so we'll have to work the addition and subtraction from left to right. However, we evaluate things by going down this list. So the first thing that we want to do is the multiplication and division. So we'll do this in the same step because they're separated. 16 divided by 4 is 4. Alright, so we don't write 16 and 4 again. Well, in this case we do write 4 again, but it's not that 4. 16 divided by 4 is 4, so I replace both of these with just a single 4. I didn't do subtraction, so I have to bring that minus sign down. I didn't use the 2, so it gets brought down to the next line. I didn't add, but now I'm also going to do this multiplication here. We have to do this multiplication before we subtract or add in the next line. So 2 times 6 is 12. 2 and the 6 get replaced with the 12 on the next line. Okay, now we do have addition and subtraction side by side, so we must work this from left to right. Left to right. 4 minus 2. That's 2. I didn't add, so I just carry down the plus 12 to the next line. Alright? And so this takes me 1, 2, 3 steps. Because now I have to add 2 and 12, and I get 14, and I'm done. Okay. Example 12, evaluate the following expression, and we see something sort of new in regards to the previous examples. We didn't have grouping symbols in the previous example, so we'll go ahead and write down PEMDAS. So we have parentheses. We don't see any superscripts, so there are no exponents. Let's look at the other operations. We have a multiply. We have a division symbol. We have addition. And then we have subtraction. So yeah, multiplication usually comes before addition and subtraction, but The parentheses could throw that off. The parentheses supersedes every other operation in this list. So here we've got brackets, okay. Here's an open bracket, there's a closed bracket. Alright. This one starts, that one stops it. So in other words, the brackets alone tell us that we don't want to multiply anything by 4 yet. The 4 is on the outside. Brackets are a grouping symbol, and that's what this P represents. Any grouping symbol, we want to work from inside the grouping symbols first. Okay, so here we have the brackets, but then inside the brackets we have another set of grouping symbols, parentheses. This is the first thing that we need to do. We want to go to the innermost grouping symbol and work our way out. Okay, so instead of writing this on the line below, I'm going to do one thing and rewrite this whole expression. 4 was on the outside of the bracket, so we definitely don't do anything with that. So I'm just going to write down these brackets. And then the divide 2, subtract 1, it's inside the brackets, but we didn't want to do that first because then we had these parentheses here. The parentheses are what we want to do first. So 13 plus 1 is 14. Okay. So we did one thing. We changed one thing about this expression, and we rewrote and copied everything else around it that we didn't address. So now we can drop the grouping symbols, these parentheses, not the brackets, but the parentheses. We could write this. That's not bad, but we don't want to just sit here and rewrite if we don't have to. We have a single number inside the parentheses. We can drop them and write it this way. Now, again, we are back to PEMDAS. Yeah, we took care of the parentheses, but now we have the brackets again. We still cannot mess with this 4 here. We have to go inside the brackets and apply the order of operations again. So inside here, division comes first, then subtract. So let me write that down. Okay, this was our first step. This is going to be our second step. Okay, and you see I'm keeping the brackets because even once we do the division, we're still going to have the subtraction. Alright, we don't want to drop the brackets until we have a single number inside. So 14 divided by 2 is 7. Okay, 7 takes the place of the 14 and the 2. And then we bring down the minus 1. Still inside the brackets. You could call this the third step. We have 7 minus 1, and that gives us 6. We don't need the brackets anymore because 6 replaces the 7 and the 1 and the subtract, and that's a single number. We don't need to write this. It's just a single number inside the grouping symbol, so we can write it as 6 by itself. Bring down the multiplication, bring down the 4, and finally the fourth step, multiplication. 4 times 6 is 24. Oh, a little too far there. Back up. Okay, here is an example. of an expression with an exponent. Haven't seen a lot of those. PEMDAS. You can't write this down too many times because you need to know it. Do we have any grouping symbols? No, we don't. Do we have exponents? Yes, we do. We have multiplication. You see this dot here. And then we have addition. So we don't have division or subtraction. Alright, and if we go down the list, this comes first, that comes second, and then this is third. So we add last. Okay, well, where's the exponent? Here is the exponent, the 2, and it's only being applied to the 6. So to knock out this first step, we just want to evaluate, and I'm going to do this off to the side. I'm going to go way over here and just say, ask myself, what is 6 squared? Okay, this is us carrying out this first operation. 6 squared is a 6 times a 6, and 6 times 6 is 36. Alright, so I'm going to go back over here and strike out this 6 squared. I have 1 plus 2 times, strike out the 6 squared. I've completed this first step, and I substitute in a 36. Alright, I finished the first step. Second tells me that I want to do multiplication, and that is 2 times 36. So what do we get there? 72. Yeah, 2 times 36 is 72. And then finally, okay, we've finished multiplication, and now we add 1 plus 72 is 73. So don't be afraid to just sort of scribble something off to the side, instead of writing this out 1,000 different times just to calculate something. Don't be afraid to scribble something out to the side and calculate it, and then take that and just plug it back into your expression. And I'm thinking this is our last example. Yeah. Example 13, we've got just about everything wrapped up in this one problem. We have parentheses, we have exponents, multiplication. Here's the multiplication right here, this 4. You notice that we don't have a minus, a division, or a dot, or anything in between this 4 and this first parentheses. That is also a way to indicate multiplication. We have addition, and we definitely have subtraction. It's here and there. So every one of these operations is involved in evaluating this expression. Alright, so I'm going to go down line by line by line by line, doing a little bit in between each line until we get a single number. Alright, the first thing I'm going to do is this. Inside the parentheses, we do all of those operations first, according to the order of operations. So 88 minus 4 and the exponent 2 here plus 2 to the third, that can just be copied down on the next line, just like this. We don't do anything with it. We're going to do one thing at a time. We're focused inside the parentheses, and we have a 7 minus 3 there, which is 4. Okay. Now, we do have parentheses left here, and it's kind of important to write it in this case. You'll get a feel for that the more practice you get. We want this parenthesis here so it separates this 4 from that 4, because ultimately this 4 is going to multiply something here. Now, the next thing that we want to take care of is this exponent. Okay. Yeah, we still have the parentheses, but there is no operation inside the parentheses to do. It's just a single number. So we have completed these parentheses here. We go to the exponents. 88 is not involved with an exponent. This first 4 is not involved with an exponent. It's multiplying. I can put a dot in there if I want to myself. This is the exponent that we're going to apply. This plus isn't involved, but this 2 and this 3 are. Okay, so I've got a couple blanks here. Before I can write a number down here, I need to apply an exponent. The 4 to the second power, and then this 2 to the third power. Alright, going to go off to the side. I've got a 4 squared. That is 4 times 4, and that turns out to be 16. I have this 2 to the third power, so I have 2 times 2 times 2. And we could have put dots there. It's not a bad idea to get used to putting dots. That's usually what we want to do in algebra. Dot, dot, still multiplication. In this case we get 8. 2 times 2 is 4. 4 times 2 is 8. Now, I strike these out. I've calculated my exponents, and I say, I'm going to try to color code this a little bit. This 16 goes right there, and this 8 replaces the 2 to the third, so the 8 goes right there. Okay, so we've taken care of the exponents, and now what do we have next? We have multiplication. Well, looking back at this, I said we had every operation, but we actually don't have any division. Okay, I just noticed that. Now, we're not going to use the 88. We're not going to subtract yet. We're not going to add yet, and we're not going to use the 8. 4 and 16 are the two numbers involved with this operation multiplication, and that's what we have to do next, right here. 4 times 16. Okay, if you can't figure that out in your head, you can always do it this way. Stack them on top of each other, and start with the bottom and multiply the top. 4 times 6 is 24. Carry the 2. 4 times 1 is 4, plus 2, 64. Alright, so no multiplication, no division, only addition and subtraction. And how are we supposed to do that? Okay, do we add first? Do we subtract first? The rule is that we want to go from left to right. Left to right. Alright. Going from left to right, we subtract 64 from 88. 88 minus 64. Okay, you can stack them on top of each other. You might want to get used to this instead of using a calculator, because again, you will not be able to use your calculator on the first test. 8 minus 4 is 4. 8 minus 6 is 2. So we can strike these out, and 88 minus 64 becomes a 24, and we bring down the plus 8. And 24 plus 8 is 32. So let's see. Not counting the little steps that we did off to the side, the calculations. We had 1, 2, 3, 4, 5 steps to evaluate this expression. 88 minus 4 times 7 minus 3 squared plus 2/3 is 32. It's amazing that that worked out to be a whole number, but it did. So just simply watching me write these down or work these out in your workbook, I'm glad you're copying them down, and hopefully you're thinking about it and trying to follow along. It's a lot of work, and I appreciate you writing this out and filling out your workbook, but it is not enough um, work, practice, in order to pass this class. So at some point, I hope that you get on Alex and get some more practice. Thanks for watching.